Hi, Doc Revis here. In this video, I will show you how to calculate the percent composition of each element in a compound. Let's get going. Percent composition in chemistry is calculated like any percent composition in math. You take the part, divide it by the whole, times 100, and you have your solution. Mass percent composition of a compound can be calculated using molar mass. The element in question is the part. The molar mass is the whole. So therefore, you'll have mass percent composition equals the mass of each element divided by the molar mass of the compound times 100 according to the formula. It is that straightforward. For example, if we had sodium phosphate, we could calculate the mass percent of each of the elements in this chemical formula. For sodium, that would mean 3 times the molar mass of sodium divided by the molar mass of sodium phosphate times 100. For phosphorus, since we only have one phosphorus, it would be 1 times the molar mass of phosphorus divided by the molar mass of sodium phosphate, which is the exact same molar mass for any of the elements in this compound. Likewise for oxygen, in this case it would be 4 times the oxygen molar mass divided by the total mass. So again, percent composition is calculated in chemistry like you would do percent composition in anything. So let's work through a problem. If we had C2H6O, this is ethanol. What would be the percent composition of each of the elements in ethanol? So we would take the number of each of the elements, use a molar mass to acquire the elemental mass in the composition, and divide it by the total mass of the compound. In the case of carbon, this will be 2 times 12, divided by the total molar mass of ethanol, which is 46.07, and we get approximately 52%. We would do likewise for hydrogen, will be 6 times the molar mass of hydrogen, which we get from the periodic table, which is 1.008 gram per mole. But in doing these calculations, we will oftentimes simply put in grams as the unit, divided by the molar mass of ethanol for approximately 13%. And we do the same thing for oxygen, the 1 oxygen times 16 divided by the number of grams in its molar mass. And we would get approximately 34%. And we can check our calculations simply by adding them up. So again, percent compositions are straightforward percent calculations like any standard math. Let's just walk through one more example. In here, we have phosphoric acid, and we want to calculate the composition of hydrogen, phosphorus, and oxygen. We would do the same thing as we did in the previous example. We would take 3 times the number of hydrogens divided by the molar mass of the acid, 1 phosphorus at 30.97 grams divided by the molar mass, and oxygen, 4 oxygens divided times 16 divided by the molar mass gives us 65.31 in this case. So there you have it, 2 examples of percent composition based upon the formula. Therefore, we use the molar mass of the elements and the molar mass of the compound.